Hello, everyone, and welcome to today's Tuesday topic. Today's topic is advice from the bench on leadership in your lab with our speakers today, Margaret Finley and Dr. Margaret Finley and Dr. Deeptha Sukumar. So with that, I'm going to stop my share and throw it over to Dr. Roseanne DiMaria Galili to introduce herself and the panel.
Hey everyone, welcome to today's Tuesday Topics. This is the Tuesday topic that's sponsored by the PhD programs in CNHP. So we're really excited to have two of our faculty, Dr. Deeptha Sukumar, who's an associate professor in nutrition science and runs a biomarker lab, in addition to many other types of labs here in CNHP. So we're really excited to hear her insights. And then we have Dr. Margaret Finley, who's also an associate professor in the Department of Physical Therapy and Rehab Sciences, and she teaches in the PhD program as well as the DPT program, and she does a lot of clinical research and will be sharing her words of wisdom about running and setting up a clinical lab as well. So I'm going to turn that over to Deeptha to start the conversation. And please, if you have questions, put them in the chat. Deeptha will speak first, take some questions, then she'll turn it over to Margaret, who'll take some questions, and then it'll be an open discussion. And thank you, everybody, for joining us today.
Thank you, Dr. DiMaria Galili, and thank you, everyone, for joining us on a Tuesday afternoon. I'm just going to spend the next 15-20 minutes or so on talking about how do I think about my lab. So I know the topic says specifically on leadership in your lab, but some of the things that I also thought we should talk about is how I think about managing equipment in my lab and different pieces in my lab. So which is what I'm going to be sharing with you. And before I get into the specifics of how I think about my lab, I just wanted to share with you what my lab does and what we focus on. So our primary interest is in understanding bone health and bone metabolism. However, I would say in the past 5 or 6 years, we have branched out into other health outcomes as well, because there is this understanding in the field of bone metabolism that bone is just not an organ that only provides mechanical support. Bone is also an organ which can be involved in overall metabolism. Now, there are reports to show how bone secretes certain markers which can regulate obesity outcomes, how bone-specific hormones can actually regulate your cardiovascular health, how specific proteins that are secreted by the bone can actually regulate diabetes and blood sugar outcomes. And recently, there's also evidence to show that specific bone-derived proteins can actually influence your cognitive outcomes. So I would say there is an explosion in the field of bone health and bone metabolism to show that it's just not an organ that provides support, but it's an organ that provides overall, which can regulate overall health and overall metabolism. So with this explosion in the field, of course, my areas of interest has also branched out a lot, and it gives me new opportunities to study all of these different health outcomes. So there are a few studies that we've completed. Some of them are still ongoing. But what we really try to understand is the relationship between bone health and what we call metabolic health. And when I say metabolic health, we try to understand how bone interacts with insulin resistance, obesity outcomes, with cardiovascular disease. So pretty much how these two factors interact. And to address this, we primarily conduct clinical trials. So we've completed a few studies in the past 5 or 6 years. We've done some supplementation studies where we try to understand the effect of 2 nutrients, magnesium and vitamin D, on cardiometabolic outcomes. We've also completed another study where we understood the effect of magnesium supplementation on metabolic parameters, and this was during weight reduction. And in all of these studies, the relationship with bone is that we are understanding how bone regulating markers specifically change with these interventions so that they can have positive effect or an influence on the outcomes. We've also completed a validation study where we've tried to validate a food frequency questionnaire. Now, this is a questionnaire which estimates how much nutrient you would get over a period of time. And we did that for one specific nutrient called magnesium, which is not very well known in its relationship to bone health. We also completed 2 cross-sectional studies understanding the relationship between bone and metabolic health in ethnically diverse populations. And we've also completed 1 other study in a clinical population, in a population that actually uses anti-epileptic drugs. So this is pretty much all the studies that we've completed. There is also 1 recent study that's ongoing in our lab where we are trying to understand the effect of a nutrition intervention and creative arts therapy intervention on various health outcomes. Again, how it really regulates health outcomes mediated via changes in bone regulating markers. So these are some studies that we've done in the past and which are ongoing. And based on all of these studies, there are a few, I would say there's a bunch of expertise that's needed in my lab to be able to address all of these questions or to be able to complete all of these studies that have been ongoing. And these are some of the things that are very, very important in my laboratory. We need expertise in nutrition interventions. We need expertise in statistical design because primarily what we do are, clinical trials. Of course, we do a lot of biomarker analysis, which means we also need expertise in phlebotomy. We also need expertise in what we call as DEXA operations. DEXA is dual X-ray energy absorptiometry, which is equipment that can measure both bone density as well as body composition. So in pretty much all our studies, we have our participants measure their bone density and also their body composition, for which DEXA operations are really important in my lab. Of course, because we try to analyze hormones, markers, etc., biochemical expertise is needed. And for certain studies where we look at a patient population, clinical expertise is also needed. And for most of my protocols, I have a physician on board so that they can help us interpret some of the clinical outcomes that are associated with our studies. One other expertise that's needed is also specifically diet counseling, because we've also been doing a lot of weight loss studies in the past few years. So these are some of the expertise that's actually needed in my lab. And if I have to think about, how I can manage all of these expertise in my lab, there are 3 distinct areas that we focus on. Of course, there's the equipment need in my laboratory. There is the personnel need in my laboratory. And of course, there is a clinical need in my laboratory. So these are the 3 big pieces in my lab. And whenever I think about hiring personnel or whenever I think about a clinical outcome, I pretty much have to think through all of these different pieces. So although it's a clinical outcome that I'm thinking through, I need to think about how will I manage my equipment? How will I manage my personnel to be able to get to that outcome? So I would say these 3 factors are critical when I think about the functioning of my lab. And if you think about all of these different outcomes that I spoke about, or all of these different expertise that I spoke about, each of these expertise will require the interaction of at least 2 of these components. So when I say nutrition interventions, I need a diet software to be able to run my program. I need personnel to be able to run these interventions. And of course, if there's a clinical significance for these nutritional interventions, I need a physician on board or a clinician on board. Again, for statistical designing, we need both the presence of a software and also personnel. For phlebotomy, again, we need all the phlebotomy equipments, we need personnel help. So if you think about each of these components of my lab, I need an efficient functioning of at least 2 or more of these components. So with that, I'll talk a little bit about what are some of the equipments and assessment techniques that I use in my research. So one of the things that we use a lot in my research is anthropometric measurements. And when I say anthropometric measurements, we measure height, weight, waist circumference, and also, of course, we measure body composition using the DEXA. So we use calibrated scales, we use tape measures, and of course, we use the DEXA to be able to give us information about bone density and also body comp. We also do questionnaire-based research because it's most of these interventions are nutrition-centric, which means we need to have a good idea of what these people are eating and what are their dietary habits. So, we also do a lot of work with food records, their medical history, because sometimes that would dictate what they're eating. So, of course, we also use a lot of questionnaires in our research. And one of the things that we use in our research are biochemical endpoints. So we analyze blood and urine to be able to assess hormones, proteins, cytokines, pretty much anything that is important as a health outcome for all of the different health outcomes that I had discussed before. We can analyze in the blood. So these are some of the different equipments or assessment techniques that I use in my research. And when I think about how do I manage equipment, so of course I'll talk about how I manage equipment, how I think about managing personnel, and these are the two areas that I thought I'll elaborate more on. So there is a bunch of equipment that I actually use in my research. So of course we use the DEXA, we use all the equipment associated with phlebotomy. And then when we go into the wet lab or the biochemical lab, we have specific instruments which help us analyze these, biomarkers in the blood or urine. So when we think about, all of these different equipments that I use in my research, what do I really have to remember or keep in the back of my mind in terms of maintenance or, ensuring that these equipments work properly? So one of the things that I have to remember is most of these equipments come in with a yearly contract to be able to, service these equipments. And, for the most part, of course, Arun Ramakrishnan, our lab engineer, he manages most of our equipment, and I'm very, very thankful for him doing this. So, we have to think about yearly contracts. We need to think about service contracts, especially the DEXA. It needs to be calibrated every year. And, if it stops functioning in the middle, we want to ensure that we have a contract in place so that, all these repairs can be done. Another thing that we also have to think about when we talk about equipment is device calibration. Because, precision is absolutely important in most of the equipments, and especially with things like DEXA and, with things like what we measure in the lab for blood and urine, it's absolutely important that our devices, our pipettes are all calibrated. So this is something which also has to be done periodically to ensure that equipments are functional and equipments are precise. More importantly, although equipments have to be working properly, but there should also be personnel engagement in managing the equipment efficiently. So especially for both our wet lab and our DEXA, we have an extensive training protocol in place so that people who are operating the DEXA or operating any of these lab equipments are well trained and they have expertise in doing this. And of course, periodically, these devices have to be maintained. There is one instrument that we use which measures electrolytes in the blood. Or even if we don't really run these markers periodically, the device has to be flushed out every now and then to ensure that it works whenever we need it to work. So device maintenance is an absolutely important aspect of managing your equipment well, and also ensuring that you have all the consumables in place. Because, for example, when we talk about our biochemical lab, there is the instrument, but there are also a lot of solutions and other consumables that are required for the proper functioning of the equipment. So these are all the different things that we think about when we want to ensure that our equipment is well managed. Then the second aspect to this is managing personnel, and I'll just give you some examples of how I manage personnel in my laboratory and how I think about how I go about doing this. So one of the things in the past 9 years, I think, that I've been at Drexel, I've had the good fortune opportunity to be able to mentor different types of students. And recently, I've also started mentoring a postdoc, which I didn't have experience with previously. But I've mentored 3 doctoral students who have successfully graduated. About 5 or 6 master's students have completed a thesis project with me. We've had a bunch of undergraduate students complete short-term research projects. I've also had some summer students, either they're MD, PhD students or some star scholars who all worked in the lab. So at some point, we've also had a lab where we had at least 10 or 12 people in the lab at a time. And of course, there have been times when we've had only 2 or 3 people in the lab. So overall, we've had different types of students at different training levels in my laboratory. And one of the things that I believe in is to ensure that there is a hierarchical model in terms of mentorship. So if there is a doctoral student and a master's student in my laboratory, I always ensure that these students are given an opportunity to mentor some of the junior students. And the junior students, the undergraduate student, the summer interns, they all report first to the doctoral students or the master's students, and then it comes to me. Now, in doing this, of course, it builds a team, and it also provides for mentoring opportunities for both my doctoral students and master's students. And it also allows for checks at different points. So this is a model that has worked really well in my lab. However, of course, we have to ensure that there are students at different levels during at the same training period. And fortunately, in the past several years, I've had at least one master's student or a doctoral student and some junior students whenever we've executed a clinical protocol. So this model works really well in my lab, and I really feel that has helped some of my doctoral students get the positions that they have gotten right now, because there is some mentorship and some leadership that was built into their training. One of the other things that I also think about when I manage personnel is, it can be an undergraduate student, it can be a summer student who's just in the lab for 4 weeks or 6 weeks. Or, in our department, we have something called senior projects that we do, where we have seniors who do small research projects. And, over the past, I think we've done that in the about 4 or 5 years ago. In the past 4 or 5 years, I've not had any. But during the time that I had these seniors in the lab, I've always ensured that these small projects are a part of a larger project. I've never thought about, having these, having short-term research projects ask their own questions. Because number one, it's not efficient use of my time, and that would not really lead to a publication if it's just a very small project. And more importantly, if it was a part of a larger project, there is something that they can be proud of. Even if they don't get an authorship, sometimes they might feel happy about the fact that they've helped in some form in contributing to the larger project. So here is an example of how I've accomplished this. This is a big clinical trial that was my doctoral students' project. So in this study, we tried to understand the effect of a combined magnesium and vitamin D supplementation on various health outcomes. And it was a large 3-year study. And one of my master's students basically published her own research findings based on just the baseline data in this project. And then some BS students or undergraduate students were able to publish a paper based on one outcome that we studied in this study, which was dietary outcomes and specifically magnesium outcomes. And they were able to publish their results on magnesium intake specifically based on this data set. So this is one way I ensure how that, of course, they have their own little data set that they can be proud of. At the same time, they can also contribute to a bigger project. Of course, when managing personnel, we make sure that their trainings are in place. We involve phlebotomists, we involve people who need to be trained on the DEXA. We need people who need to be trained as a dietitian to be able to deliver weight loss interventions. So I always make sure that, we have all their certifications in place. We have their trainings in place. So everything needs to be in place before they even start any kind of a work in the laboratory. And of course, they need to have expertise in doing that. So in some cases, we don't really need a training as long as they have an expertise. For example, for the biochemical lab, there's really no formal training except the BioRaft that's needed. But as long as they've had expertise in doing that previously, we're able to include them in the laboratory. One of the things that I also do that's very specific to my lab, and this I've learned over the course of many, many years, is that We have different pieces in my lab. Of course, we have things that we need to think about when we do phlebotomy. For example, there are so many number of tubes that I need them to draw the blood on. When it comes to collecting urine, I need to make sure that they collect urine in a specific container in a specific amount. When it comes to DEXA, we want to make sure that scans are done properly at certain sites. So it's very, very difficult to ensure that this information is correctly passed on unless and until there is a written protocol in place. So pretty much anybody who comes into my lab, I have them read and sign a lab standard operating procedure document. So this document, I would say, is like a 13-page document that we just developed, me and my doctoral students have developed over the course of time, where we talk about different things. We talk about what should be a dress code if you actually come in for a clinical visit. And there are people who are talking about their medical history. There are people getting their weights, they're getting their blood drawn. So we want to make sure that our clinical team looks presentable and they are dressed properly, appropriately when a participant comes into my lab. So we talk about what are some of the things associated with dress code, how many tubes to draw, what kind of tubes to use. So we talk about all of these different aspects. And again, if you go into the biochemical lab, what is the dress code for a biochemical lab? Because, if you've done a bioraf training, it has to be closed shoes, it needs to be a laboratory coat, and as needed, a goggle. So all of these things we reiterate in our SOP. And most of the people, all the students who come into my lab would read through this, and then they would sign a document saying, they've gone through this and they understand all the procedures. So again, these are the different pieces in my lab. Of course, I don't talk about clinical as much because this is an expertise that we borrow from outside whenever we need an interpretation of the data. But of course, equipment and personnel are something which are critical pieces in my lab. And as I've shown you, it's very, very important that there is a cordial working relationship between these three pieces. And, we work in unison to be able to accomplish and answer questions in my lab. So with this, I will, do you want me to take questions now, Darren?
Sure. Does anyone have any questions for Dr. Sukumar? Thank you, Deeptha. That was really, really informative and useful.
Yeah.
The one thing that sort of struck me as I was looking at your slides is that, for each project, you have an intersection between equipment, personnel, and clinical.
Yeah.
But personnel is the key in all of them.
In all of them, absolutely.
You got to have people to bring those things together.
Absolutely.
Ben, you have a question?
Yeah, sure. I wasn't sure if to ask now or later, but for us starting up our labs, how do you know when, I guess, to bring in the right people, or what order is it best to bring individuals in? Like, I know it's easier to get undergrads, but you probably need a grad student to, like you were saying, for your hierarchical model, to mentor the undergrads. How do you time that recruitment of individuals, as well as kind of understanding that work needs to get done and you need individuals to do it? So how do you balance all of that, especially when you're starting up?
I think it depends on the need of the project, and maybe this is something that, Margaret, you can also jump in later on. But I felt that the personnel that I need in the lab at any point really depends on what project is going on. Now, sometimes it's a smaller project, which in my case involves questionnaires or things like that. Then I'm able to accomplish the project goals with an undergraduate. However, if it's more complex in terms of involving, biochemical needs and DEXA and things like that, number one, the undergraduate student does not have the time to be able to accomplish all of these things. So if the project is more complex, then I absolutely would need somebody like a doctoral student there, or in some cases maybe somebody like a clinical coordinator if I have the funds to be able to pay someone like that. So absolutely dictated by the needs of the project, I would say.
Thank you. Do we have any other questions from folks? You guys, if something pops up as Dr. Finley is presenting, you can always pop it into the chat and we can circle back and answer those questions a little bit later. All right. So with that, thank you, Dr. Sukumar. Margaret, I'm going to highlight you, and if you want to start your share. You're muted.
muted me again. All
Okay.
right. And okay, so everything's up and running.
Yep, you look good.
Okay, great. So as we start with this, I'm going to start with a caveat that my lab and the way my lab runs is very different than Deeptha's lab because of the focus of it. And so I have it set up and I'm building, and Ben, thanks for asking that, because for me, personnel is very much project dependent and how I make those decisions. So I really start with, and I ask people, what is your definition? I am a clinical researcher. I am not a bench researcher. So I am always dealing with just the human side. So all of those bioraft things that we all take, those really don't apply. So I don't have the need for my personnel to have those skill sets. So our skill sets are different. And often I'm finding that they're dependent on the project. And in thinking about this and the way I layered this talk, and my aspect of it is thinking back of how do you set up the lab, and thinking where you are, Ben, is that startup. When you come in new, whether you're brand new and you've done nothing or you're changing institutions. So the first thing is that startup, and whether it's your startup package or what. And I think the most important, using an a priori decision about what my lab is going to look like, is I got to start with, what is my major agenda? What am I going to be studying? I came to Drexel with at the time, the research I was doing was different than what I transitioned to once I arrived here. So, and that was a decision I made, a little bit of a shift. Actually, I went back to work that I'd done more in my dissertation postdoc and earlier days. So that research direction, in thinking about, I have an empty room and I need to buy equipment for it. How do I make that decision for that equipment? I'm not even thinking personnel at this point in time. I'm thinking, if I'm going to start doing research, how do I do it? So I have to think about that, my research direction. And, and some of that you also want to think long-term. Whether I completely did that successfully in the beginning, I'm going to say probably not the best in thinking ahead as my direction has changed. But you think about that. Another thing is, who will be your collaborators? And I'm not thinking about identifying people. I'm thinking, what do they bring to the table in the land of, as Deeptha mentioned, all of that expertise that her people need with the phlebotomy, the biochem, to me, those might be completely different people, whether they are personnel I'm hiring or collaborators. So what do my collaborators bring? Not just their skill set, what equipment do they already have? So if part of my study is done in their place, where can I get that covered? The next one is, what already exists where I'm going? I came into a department that had, at the time I came in, 4 of the faculty were biomechanical researchers, which was my area as well. So equipment already existed. Some of it may have been older, but some of it was there that I would be able to utilize in my work. And within that, as well as coming into a team environment, whether we're each studying different areas, we can share equipment, which is a big thing through CNHP, is can we get something that is, can be utilized? So I had conversations with my soon-to-be colleagues before I ever came as to, if I'm going to be looking at this, what things might benefit you as well that you might be able to utilize. And so that's where we look at what might others need. And with that, my work, again, I started out is I needed to get newer equipment for biomechanical analyses. And so with that, I have to research vendors. I have to research what are the space needs? What are the other aspects that will be there? And ultimately, when I first came in, I made the decisions on 2 big pieces of equipment that I still use today very heavily. And what are we going to do with that, and how other people can use it? So these are the 2 big biomechanical tools. And as Deeptha spoke to, it has the software components. So with personnel who will be using it, we have to train individually on projects as they come as to how this equipment is utilized, how you set it up, and how you modify it. So our SOPs are based on projects. And so each project, we develop a step-by-step manual of what needs to be done. What are the considerations in preparation? How do we actually run this? As I usually say, what button do I press? and proceeding through analysis. So those get set up project by project with that. So we need to think of that. So I had this, but you come in and then you start your study and you need more equipment. And I didn't even consider when I put this together, hearing Deeptha's talk about the consumables. My equipment, there are things that we use over and over, and all of those have to go into your considerations about those. These two small pieces of equipment I needed for my first seed pilot when I came in, and they were several $1,000s more. So I had to think about these little pieces. It's something about the smaller they are, the more expensive they are. But I hadn't really thought through those little details. So initial really thinking about what your first projects might look like and investigating what's available for equipment is very important. For me, personnel really is a very different direction because it was really going to be based on the study that I was running and how many people do I need to assist me and what other experts would I need with it. One of my favorite things is that with our labs, when we buy equipment, the vendors come in and set them up, and it's a 3-day event for this. And I love this picture. Over here, she's now the president of the company. This is a former colleague. This is our big sensor. And this is this is one of our blue trash cans, but that's what we sit these $50,000 pieces of equipment on because they're electromagnetic. To buy this grade trash can that we needed was several $100s, little things you don't think about at the time. And when Deeptha mentioned calibration, when we set up our equipment in our environments, a lot of times the vendors are in there to help us, and we had that. We had to calibrate this force plate with the electromagnetic, and we didn't have a stylus heavy enough. So we found this rack in a closet, and you have to weight it. That's my son. We were doing this at night. He was 9 at the time. He's 16 now. We literally hung him from this to calibrate our equipment and get our lab going. So sometimes in the land of biomechanics, we talk about a lot of duct tape and brute force. So, a lot of times you got to think about, how do I get the physical lab set up? It involves how do I set up the environment itself? Some other considerations, once you've got your equipment and you're getting ready to start, on top of those equipment costs and the setup and calibration of getting your physical environment so you're capable of collecting your data, is the annual licensing fees and maintenance agreements that come with the equipment are also quite pricey. So you need to, our original equipment, our annual licensing fee was almost $5,000. So making sure you have those funds to cover it over time, because those are things that'll get you if you're not in consideration about, how do I keep this equipment going? And so that's something upfront that you need to investigate and understand. So some of those considerations in setting that startup lab is looking at your immediate, what you're doing, and then carrying it forward and how it would work. So in going into my first large funded project, it was a multi-site longitudinal clinical trial. There were some things that I learned there. My lab now was going to look different because I was collecting data on site as well as off site. So my equipment, I had to get additional equipment. And based on the funding, we had to get this portable equipment. And I built some of it into the grant, but I became aware that my very large system that I had purchased in the first picture was not going to be as portable as we needed. So I had to find ways to fund and get another system that was portable so that we could collect our data at a different location. So when you go to where not only did I have a second site doing data collection, we were actually going into McGee next door and collecting data on site. So to be able to do that, we had to have portable equipment that we could take with us. This is portable. If you ever saw us moving it, it's quite cumbersome, but it is portable. So thinking about those things, if you are going to be going somewhere else into, I'll say, the community to collect data, do you have the appropriate equipment to do that? And from this study is where personnel came into play, is now hiring the people. I had a grad student with me. I had collaborators, and we were the ones collecting all the data. Again, knowing that expertise in biostatistics, we had those people on the grant. So at that point, I was not hiring additional people. But one of the things that I did learn over time is this study, this was our initial group. We had lots of personnel. This is 1/3 of the team. So we had about 15 people that started on this grant. We lost lots of people. In the end, it was just Liz, the grad student, and the biostat and myself out of the original 15. So had we hired, perhaps built into that research coordinator, perhaps we would have had some assistance on it. So personnel changes throughout a longitudinal project are something that happens, and making a deep thought up front in your planning phase or what equipment you would need, the cost of those equipment, because along with that new equipment, I had additional licensing fees annually. And then planning on personnel. If someone leaves, what are the role changes? Maybe having that, this was a lesson I learned, having a strategic plan of what happens if this personnel leaves. And I think about that as some as Deeptha's lab. If in the middle you lose someone with expertise, how do you fill that void? And that's something to consider up front. And that was a lesson I learned a little bit the hard way. So then again, my lab now is very different in a lot of ways. Is we've moved into the community and we're looking at tele-exercise. So what we have now here, this Zoom, this is kind of my lab now and how we're engaging with people. We also have taken it out to the community, and that takes that. So our equipment's very different. Our equipment is, people have their own, you have your own Zoom and your own computers. And so we're relying on some IT support with some of the things. So that's a very different environment of a lab. So that's my lab different now. The personnel, again, as our studies are getting bigger, we have a research clinician who happens to also be a PhD student. We have consultants that have joined us from across the country, one at the VA in San Diego and several others. The bigger one on the personnel, that have been added to my lab, are individuals with lived experience. And we are currently studying individuals with spinal cord injury, and they are part of our study. They are part of our lab now. They're on our IRBs, and we're engaging them from every step. So that is one thing that's really important in developing a lab as personnel, is community partnerships, as we hear that. And whether that's a partnership with an organization, which we've done that with several local and national ones, or personnel, which are individuals that you are developing these relationships and almost through a qualitative term, snowball sampling to get more of those people. We have an SCI LEAP, a lived experience advisory panel, and we're up to 8 or 9 individuals who have signed agreement letters with us to participate in our studies. They provide letters for our grant applications. They're available to provide input as consultants. We pay them usually through gift cards at this point. And one of them has actually been employed as a co-leader for our tele-exercise. And we got her employed as through Drexel and got paid for that. So how you get these individuals with lived experience, many of my grants require at least one person on it, but we now believe that it's richer with a larger panel. So my personnel have started to look very different. They're in the community, they're not, and that community is national. It is not just sitting in my lab on 3 Parkway. So a very different perspective on that than as we see in other situations that I've run. When we were talking earlier about this, it was, my current lab organization chart and my mentoring style with them. And I started thinking, I don't have this big breakdown in my lab. Right now, you got me up at the top as the primary mentor. I currently have 2 PhD students who are candidates at this point, and their areas of interest and expertise match the 2 lines that I have. One is very biomechanical, and that is Liz, and then Laura is in the tele-exercise. With that, I'm mentoring them, and they mentor each other. Laura has come into the lab and assists Liz and has learned the biomechanical tools from a level of just experience with them. Liz has demonstrated interest in coming in to be involved in some of the more qualitative mixed methods side, both of them gaining experience that will help them when they go forward building a resume of experiences and getting both of them the mixed methods and exposure to biomechanical tools for Laura. And from that, and this gets kind of what Ben was asking about, is how do you know when to hire which individuals? Well, we've learned in bringing in people for our situation, we have a large pool of DPT students. Some are interested in research. However, their schedules are absurd. So we rely on several who express interest, and we bring them into the lab. They're working with Liz. She now is mentoring them in how the biomechanics are collected, as well as some of the clinical implications of the work she's doing, and helps them apply that. We also have actually borrowed a few co-ops who have been working with colleagues in our department, and Liz has worked with them as well as a couple other undergraduates through health sciences. And they come in and they assist with her in her data collection, and she is getting to mentor them and teach them her process. For Laura, the big one has been that she is managing and mentoring our community partners with spinal cord injury. And as they are training in to become co-investigators on our studies, and she'll be working with them in the process of city training. And as the last one co-led our exercise program over the summer, it was Laura who got to mentor her and direct her through that process. So depending on what my lab looked like and at what time we're looking at things, whether we're in the lab biomechanically or in the community, which for us is a virtual community, is how it looks for us. And that is what depends on my equipment and my personnel. And in the third one that Deeptha had as clinical is we are fully clinical. So as being a physical therapist myself, that is always integrated in my work. And we pull that in from various perspectives. The consultant in San Diego is a clinical rehabilitation psychologist. So we're bringing in that clinical aspect as well in our work. So finding those other individuals to be personnel on specific studies is how we have been developing the lab. And so that at this point is pretty much how my lab looks, which I always look at. It's like, I don't know what my lab looks like at times in a physical perspective. But this is, I guess, these are my two lab environments as from beginning when I started here to where they are today. So
Great.
anybody has
Thank you, Margaret. That was really, really, very, very insightful. Does anybody have any questions for Dr. Finley or Dr. Sukumar? I have one for you, Margaret. So as you were, what are some of the different technology or equipment asks that you require for the people who are joining you, who are in your virtual lab, like the folks who are connecting via Zoom? I know,
Well,
I imagine you had to do a sort of a mental shift when COVID hit about how you can make your physical lab and your virtual lab.
COVID helped us actually thrive and develop this tele-exercise. Laura's side of things kind of thrived during COVID because of how the interest grew. And the equipment is essentially, to be involved, people have to have some technology. And as we know, majority of people have at least a smartphone, and people joined our programs from a smartphone or a computer. So that was inclusion, had to be internet access. So they had to have that on their own. Our technology was going through Drexel and saving it through the Drexel via my streams so that we had access to our videos and such. Equipment for our people that participate, that was I purchased and was mailed to them. So if they needed exercise equipment, we mailed it to those individuals that needed it directly to their homes. So there was no contact.
Great. Thank you. Ben, do you have another question? No, you just turned your face on.
Yeah, just show my face.
Great. Deeptha, do you want to add anything about like how your lab life shifted as COVID came in, and how maybe things have shifted a little bit for you recently?
So, fortunately, the time when COVID hit was a time when pretty much all my doctoral students were in the phase of defending and, in the phase of data analysis. So I think it was a well-needed break from this active clinical, engagement that we had, constantly running behind doing biomarkers and, DEXA analyses and stuff like that. And we got this time to be able to, finish up, first of all the three of their data analyses and all that. But, we've been able to use this time to be able to run some additional statistical analyses, to be able to think through questions that we had not originally thought through in their original dissertations. So I think we've been using most of this time, synthesizing the data, understanding the data, publishing it, analyzing it. That's pretty much where most of our focus has been over the past several years. Of course, writing my own grant applications. But we've not been able to do a lot of clinical activity. But again, thankfully, it happened at a time when most of our major clinical activities ended. So we're just restarting our clinical activities right now.
Great.
And Darren, I'll follow up on that as I had my parallel. Laura had, with her interests and how things go mixed methods, COVID wasn't as big of an obstacle. The other side is we were shut down biomechanically. Liz was not at it. She was just a proposal. So an entire year went by. And one of the other aspects, when we talk about a mentoring shift, what some of it even happened today, is the software that goes with my major biomechanical equipment I've worked with for 23 years. And the February of 2020, they retired it and went to an entire new platform. Oh, no. And so Arun was in the process of updating our two equipment. COVID hit. So we're like, let's just wait because we can't come in. So a year later, we got back to something that looked nothing like I had ever worked with. So I was brand new. So Liz and I are back in the lab learning it. And she's now collecting. She's able to get people in within, that's what she's in a data collection right now. And we were trying to look at some things, and it's so different. We're going back to our help desk with our maintenance agreement and talking to them because we're trying to figure it out. And she's talking me through what she's done because it is so different. So not only did it shut us down, they decided to change everything and COVID hit. And so we weren't even on it for a year. We couldn't even look at it for a year. And so we had to fully re-ramp up on, we had to put in every program, every protocol, everything from scratch on new software. So it became co-learning, the two of us with a student, on how this worked and how it's moving forward. It's going to require a lot of, she uses it all the time and I don't. So she's mentoring me on some of it, on steps as we're relearning it.
That's great. I'm sorry, but that's great.
I felt I was too old to learn something that new, but I'm trying.
Right. I do like the she's mentoring you. That's a nice little sort of like dynamic shift that tends to occur. I just have one last question for you both as you were sort of thinking about asking for your startup packages. I know, Margaret, you mentioned that in your presentation. Is there anything that you, for new folks, for folks who are just starting out, that you would want to make sure that they include in their asks, in their say they've just gotten a tenure track position, they're starting a what's the one thing that you want to make sure you have included in your startup package?
That's a hard one.
I would say miscellaneous. Really, miscellaneous.
Well, in thinking, one of the things, and it's as the chair of our search committee, and that's something I'm not allowed to even mention and talk about. And as Ben has just gone through it, is that becomes part of a negotiation. That is really your hiring negotiation, and having really good mentorship from behind, talking to your mentors about what to do for that, as well as potential people who are already there can help you with that, because it's a big negotiation. And I think one of the biggest things, and especially in the environment we're in now, is ask for those PhD students, because we now have to fund them through grants, and they're a very expensive part with tuition remission as well as stipends. So definitely get graduate students as part of your startup, get some of that personnel that you can then work with, because I think they are very critical to helping you get your work going and to get your lab going. So, equipment is one thing, personnel, equipment, and clinical. I think startup is some of the personnel.
Yeah, I mean, I think oftentimes people think of I need this equipment to be able to get done what I need to get done, and they don't give as much thought about how having the right type of person to help you achieve your goals is really critical.
I would also add, thinking about personnel as, either a doctoral student or somebody like a clinical coordinator. Because remember, a doctoral student has a lot of commitments the first 2 years when it comes to their courses. So it really depends on the need of the project, because there's only so many hours that the doctoral student is able to devote, especially in the first year. So if the need of the project is such that it has to hit the ground running, then maybe trying to budget some of that money towards somebody like a clinical coordinator who's here 100% in the lab, being able to coordinate different aspects, rather than a doctoral student who may not be available during the first year as much. So it really depends on what the need of the project is during that time.
Great.
And then
Yeah,
once they hit the ground running, then the doctoral student can always catch up. They can be still involved initially, not 100% of their time, maybe 20, 30% of their time that they have during the first year. And once the project has hit the ground running and it's in a good pace, then they can hopefully catch up. So,
do you have something you want to add, Margaret?
I think people are harder to identify than equipment. So I think personnel is something to think about before. Yeah, your equipment, you can figure that out eventually. Personnel and what kind of you'll need at the time. And as Deep said, that a clinical coordinator, I'm thinking in terms of coming in and not exactly having your exact project that you're starting day one, in thinking of, get some students and work together. But a clinical coordinator, someone who can help you with things, I think would be very useful.
All right. Well, if we don't have any additional questions, thank you both for your questions. I see a applause there. And thanks for joining us for today's Tuesday topic. And thanks. I'll see you guys next week.
thank you, Darren. Thanks, everyone. Have a good night.
Thanks, everyone. Thanks, Darren. Have a good evening.